Right, okay, that sounds positive. Something's working, which is good. So good morning, everybody. So we're here for the Ardari session this conference, Research Data Architectures and Research Institutions. And we're going to be looking at the role of middleware for data and metadata management, and in particular, middleware that is iRODS, which wasn't necessarily a sort of a conscious choice, but it's turned out to be it's a popular tool that people are already using. So all three examples that we're going to hear about this morning will be using that. Before I go any further, I'm going to work out how to use the clicker again. Just highlight the right thing. It's got it. Okay, so this is the agenda for our session this morning. That QR code there links to the collaborative notes, and I would encourage everyone here to open the collaborative notes up if you can get your phones to register that. Do add your names and institutions to the attendance register, and if you want to participate in taking the notes, that would be great if we can just make that a combined effort. So I'll just start off with a little bit of an introductory slide. We're going to have three short talks this morning, but the emphasis of the session, as we usually try and do in these sessions, is really going to be about a structured discussion involving you, the audience, and the people joining us online. So whilst you'll get an opportunity to quiz the speakers on what they've been talking about, we try and run these sessions very much as a kind of a community who's here to exchange knowledge, learn from each other, find out what you've been trying out, if anything, what works, what doesn't, as well as dealing with questions and things like that. And we'll just wrap up at the end and leave a few minutes for that. So perhaps the first thing to cover is what our group does. We tend to get a few different people each time, so we always explain what the remit of the group is. So basically, research, data architectures and research institutions, which is a bit of a mouthful. Apologies for that. Interest groups primarily concerned with the technical architectures for managing research data within universities and other multidisciplinary research institutions. So I should actually qualify that. So in recent sessions, we've been finding that there's a number of sort of national or regional bodies who are working to actually provide infrastructure and tools and services for universities. So we do very much include that as well. And you'll be hearing from SURF as one of our speakers this morning that will be addressing us in that mold. The group provides insight to approaches being taken to development and operation of such architectures and their success or otherwise. So if you have brilliant success stories, share them. If you have terrible disaster stories, share those too, if they're not too embarrassing, so we can all learn from both sides of what happens. A very small introduction to middleware. So middleware is a term that can cover all sorts of different things, and a quick attempt to confirm my slides on Google yesterday rather confirmed that the term has a million and one different uses. But essentially, it's the glue that connect different software platforms and devices together. So anything that fits in between operating systems, infrastructures, software running on top of those to help improve things and add additional services. It's a means of connecting different architectures. Application programming interfaces are a good example of what middleware is. Data integration tools can often take the form of middleware, and policy engines in particular. So iRODS, which is what we're going to be talking about a particular bit, is well known as being a sort of policy engine where you can automate certain decisions. We will, after our speakers have spoken, be running through a number of kind of different topics, and these are some suggestions of the kind of questions we'll be asking and looking to explore as a group. This is not supposed to be a limited list. If people have other things that they would like to talk about, to discuss, that's absolutely fine. But I think now the time has come to introduce our first speaker, who is Ingrid. Ingrid, I will scroll you onto the screen so that people can see you. Let me just move you across there. In the top corner. Welcome, Ingrid. Do you want to say a few words about yourself and then get started? I'm not sure you will be able to move the slides around, so if you kind of say next slide, please, I shall work the clicker and try and get it to go in the right direction.
Excellent. So, yep, can I start?
Yes, absolutely, go for it.
Okay, thank you very much to invite me to that session. I'm going to present or talk very briefly, because 10 minutes is really about the platform that we have been developing over the last year and a half, 2 years, and that we are about to launch in production. So it's called Mango, and it's an active, it's a platform for active research data. So I think, next please, I was now trying to, yeah. So I think if everybody that have been talking with users, although they understand the importance of research data management, they feel a little bit overwhelmed of all the things that they need to do to manage data properly. So from tackling the dispersion of data, data gets everywhere and nowhere, nobody knows where, how to collaborate, share data, data security and protection, obviously, but also about how to work and standardize a little bit the work, the managing of data and the data documentation, and especially is any automation in terms of can we avoid repetitive tasks. So we've been talking with users, we've got this feedback, and we, among other activities that we have in research data management in KU Leuven that are larger than just only that platform, we decided to start building a platform for active data management. Please, next. So the idea is, it's Mango is that platform, and we like to call it, it's a bit marketing, it's like data management as a service. So what we heard from the users, they need a place to store data. Yes, so we are providing a central storage, also trying to tackle also the price problem, and they always complain about the price. So the idea is to centralize data in one central storage to avoid dispersion of data, to avoid duplication, but also increase the accessibility to data and also the security of data. But it's not only about the storage. We also wanted to provide all other data management features, and here enters the metadata. And this, by providing tools that also allows to describe data using metadata, increase the standardization, increase also by providing tools that allows for automation, the possibility to reduce the repetitive tasks, and also provide tools for data discovery and collaboration. So the idea, we hear it often about FAIR, but it's often always in the publish after the data has been published. But the idea is help users to apply the FAIR principles from the very beginning of the project, from the start. So I'm going to be stretching a little bit things, and I'm going to show our platform how we show these FAIR principles. And we try to provide tools for doing these FAIR principles. Next, please. So how are we doing that? Actually, we are using iRODS. So we have a storage. We recently bought 6 petabytes usable storage, double copy, and we are on top of that using iRODS. Why? Because it helps us with a little bit the virtualization of the storage layer, and also then we use all the tools for metadata and automation. So we have different deployments of iRODS, different zones, and we have at the moment about 5, 6, but the idea is to be able to scale that. There are some generic zones where small projects can go there, but we also create a specific zone, separate zones for projects if they have confidential data or they are very large projects. On top of that, we have also different clients. Some are provided by the iRODS consortium itself, but we also have develop an in-house Mango, the portal, that's called the Mango portal, a graphical interface. And I'm going to show what I'm going to show now is mainly showing the Mango portal, but most of the things I'm going to show are also able to be, that can be done with any of the other clients, but just what visual is nicer always the portal. Next, please. So the first findable, if we start with the findable, what the portal and the platform Mango is providing is a tool to be able to search data easily. We have a global search, kind of a more Google-like search that's based using open search. We pre-index the objects and collections, and you can search there at the moment based on file name, collection name, owner, but also a number of metadata fields, like for instance title, that we know that we are going to be increasing these indexed sets. But on top of that, next please, we also can have a little bit more advanced search, and users can search by using by data objects and collections based on the name, but also contains or starts from, or also base the data was created or modified on a specific date. And also, and that's a very important thing, they can search based on the metadata attributes that has been added to the objects and collections. Next, please. Also accessibility. So we like to talk about Mango, about data everywhere. Why? Because Mango is accessible from many different platforms. So instruments, as you are talking about active data, instruments can write directly in Mango. Users can connect from their laptops, desktops, or if they are using HPC, for instance, we have our tier 2 and tier 1 HPC infrastructures. They can also access the data and use data from Mango from their HPC. And this can be done from different Linux systems, Windows systems, and Macs. That's very important, accessibility of the data. On top of that, we are also working to be able to integrate Mango portal together with repositories, publishing repositories, to be able to push and pull data from them, and especially our own institutional repository Radar that is based on Dataverse. And that's work that's still work in progress. Next, please. And we also, Mango, one very important aspect of our platform is the metadata. We were from the beginning very convinced that we should not only provide a storage is already there. We have also other systems, but we wanted to provide something that also was allowing the users to describe the data and add metadata, a rich metadata. So we use the features of iRODS about the possibility to add user metadata. This metadata can be added manually, obviously. iRODS is very simple in metadata, is attribute value unit as a triples. And but we are especially working on providing tools to allow users to create schemas, metadata schemas for standardization, but also working a lot on automated process to extract metadata from the file itself. Next, please. So as an example of this is for me what is interoperability, in the sense that in this case, interoperability between humans, that people can understand the data, and by describing the data properly, that people knows where the data is, what the data is about. So we have created in our portal a system to create metadata schemas. This way we can avoid, minimize the user mistakes, allow for some data validation, because we can create data types, and then we can decide, the user can decide if some of the metadata is compulsory or optional, and that allows to create very rich metadata schemas, and that domain-specific metadata is possible to be. We have a system to, like a life cycle for the metadata schema, so people start with a draft. Then a draft can never be used. This draft is published, and is once the metadata schema is published, can be used. And if it's modified, there is a versioning system, so it's only one version at a time that is active. And then if you can archive this schema, the data that has been the data that has this schema, has used this schema to apply metadata, stays there, but it cannot be used anymore. So it's a full life cycle. And then we have created in the portal a system for metadata schema manager. So you see here a small snapshot. You get all your schemas, and you from there can create now new ones. Next, please. And once a person wants to create a new schema, next, please. So you can give a name, and then, for instance, they can create different elements, text inputs, select inputs, checkboxes, combine objects, etc. So that's really growing, and we are really work in progress. And this is even a little bit older snapshots, so the new versions are even more extended. But that's just to give you an idea of what we are doing. Next, please. So another work that we are trying to do is about the automation of the metadata. So it's nice to have schemas, but at the end there is a manual work that needs to happen to apply those schemas. I didn't mention, but those schemas can be, so in one object, people can apply multiple schemas, and that allows to it's very easy to combine schemas in a same object of collection. But we are also trying to work, and we are develop a kind of a proof of concept to use Apache Tika to extract automatically metadata from the files, all the files that, for instance, this is an example with a PNG, an image that already has metadata embedded in the file. So what a user can do is inspect the metadata by calling this tool that checks the metadata and shows it in the interface. We can inspect, and then we can select some of those metadata fields to be imported to iRODS automatically. In this way, it's almost, we call semi-manual, because you can inspect and select, but there's almost no manual interaction, and there is nothing that needs to be typed, and errors can happen. The moment this metadata is added in the system, it's ready also for discovery, so can be used on search. Next, please.
Okay, 2 minutes.
Yeah, as the last slide, or 2 slides, but so in terms of reusable, how do we apply the reusability? There is 2 things. One is collaboration, and the other one is sharing. In collaboration, we use iRODS ECL permissions. That means that people can establish different groups, and then you can apply these permissions based on groups and then in this way you can share data inside the system, inside one zone, with the people that also has access to the zone. And for having and sharing data with people external, we have also have a Globus online on top. There's also a connector for iRODS, and we are using that to expose all data that is in Mango, and to be able to transfer data between different storage systems and to share with externals. Next, please. I think I'm done. Yeah, so that's all. I know it's very fast, but I hope you got an idea what we are doing, and I'm really looking forward to hear from the other experience and for the feedback from the team. Thank you very much.
Thank you very much, Ingrid. Now we'll have a general conversation at the end, but I'm going to put aside a couple of minutes for any direct questions for the speakers, I think. So if anybody has any questions specifically for Ingrid, happy to take them. Is there anything online, Keith?
No, there's nothing on. Oh, here. There is a question, but I think we can save that for the general.
We'll save it, right? Okay,
that's going to be probably a question which is relevant to all 3 presentations.
Great. Okay.
So I have a question.
Yeah. Okay. In the back.
Ingrid, how would we implement Mango in every other university, for example, if we would want to?
Sorry, because the sound is a bit
How could we implement Mango in every other university?
Yeah, so we are planning to, especially the portal, iRODS is open source, so that's possible. And then we are planning to open source also our portal. So that's something will be probably happening in the summer. So the idea, what our design is that everything is configurable. So it's possible to really apply those implement it for you and make a deployment for your own. Everything is quite general, and you can configure everything that is your own policies. So we plan that, yeah. I don't know if these answer your question, actually.
Yeah, it does. Thank you.
Excellent, thank you. Okay, so let's move on. So Ingrid, I'm going to scroll you off the screen. Apologies for that.
Yeah.
There's a more sort of technologically slick way of doing this, but it's the method we've got at the moment. And okay, so Madili. Now I'm going to leave you with this. I'm going to try and retreat out of the way so I'm not in the middle of voice like all the time. Yeah, that's the one to move it forward.
Thank you. So, hello everyone. I am Kristam from SURF, and today I'll be talking about how we use the iRODS technology and stuff. And actually, Ingrid's presentation, the general idea of RDM, FAIR principles, and those I can build up on. So that's good. Before I move into, let me go back one slide. To keep it simple, I'm going to make an assumption that you know a little bit about iRODS. if you don't find me during the coffee break, but because of the duration of the presentation, I'm not going to give an introduction to iRODS. The second thing is that because I expected a wide audience, technical and non-technical, if you want to look at the details of how the iRODS setup looks like, try to read the slides. Otherwise, just follow what I'm saying and I'll walk you through it and hopefully give you a fair idea of what we are trying to do at SURF. Okay, so first of all, what is SURF? It's a cooperative for IT in Dutch research and education. So what is a cooperative? It means that we have members, which are universities, medical centers, vocational education institutions, research institutions. And how do we support IT for them? We do it via services. So for example, if you think of the compute services, we host the Dutch National Supercomputer. We are a tier 1 site for grid storage and compute. We have cloud services, network infrastructure, and of course, data management, which is what we are going to zoom on now. So we have 3 services in this context at SURF. The first is called the iRODS hosting service. So basically you have one iRODS dedicated instance for research institution or a university. And this is what the setup looks like. So the different components of iRODS are spread across 2 virtual machines, and they sit on SURF's own OpenStack cloud infrastructure. And from a user perspective, there are 3 different storage resources that are available. One is Ceph, which also provides the block storage for the cloud infrastructure. And then the other 2 that you see there, these are also standalone resource storage services at SURF. One is the object store, and the third one, the data archive, which also gives the tape backend. So if you want to have a lot of data at a lower price, then they can use the tape. And for users, there are a variety of clients that they can use to interact with iRODS. Now, for those of you who don't know iRODS at all, basically, this is what you need to know, that you can interact with this and you get different storage backends. And as a user, you don't really need to worry about what data sits where. If you want to make copies, you can tell iRODS, say, make copies for me on these different storage services, it will do it for you. So this provides basically an abstraction layer for you, and that's how the users see it. The second is what we call the iRODS scale-out service. So here you can see that the colors are not showing well, but there's a left and a right block. And the right block is the storage side of things, so to say, and they are hosted at SURF. So we have a resource server and the 2 storage resources that I mentioned earlier. All the other components of iRODS, they are hosted outside of SURF. So for example, at a university or a research institution. And they can choose what setup they want. So for example, they want to have the different components of iRODS across different servers. They want to have their own storage backends on top of what's being provided at SURF. So this is what the setup would look like. And the idea is that these are use cases where the universities, they have the in-house expertise to host iRODS, and they also want to have full control of it, but they want to scale out the storage at SURF because, for example, maintaining tape library is expensive, so they don't want to do it themselves. So then they use the SURF services for that. And the third service is what we call Yoda hosting. So Yoda is a platform that's built on top of iRODS, and it was developed at the Utrecht University. It's very popular for hosting web-based workflows. So what all can a user do just via the web portal, for example? So you can organize your users into different groups. For example, you give the user a researcher role or a data manager or a data steward role. And I'll explain in a moment where these roles come into picture. The data itself is stored in 2 different locations, not physical locations, but virtual locations. One space, as we call it, is called the research space. So this is where the initial data goes in. The users can collaborate, interact with it, and do their research. Once that part is done, they can add the metadata to the data. And in Yoda, you can also have predefined templates so that you can have uniformity in the metadata that you add to the data. Once that step is finished, the users can then publish the data. And the data set that is published, it rests in the second zone. That's what is called the vault in Yoda. So if you think of a typical cycle, when the researchers are done, they add the metadata, and then they say, I want to publish this data. Then a data manager gets a notification and says, okay, I want to either approve, reject, or suggest some changes to the metadata. And once they approve it, then the data gets published. So you then have an extra pair of eyes principle, and then it can be as harmonized as possible. And all of this you can do via the web portal. But you can also upload and download data using the Yoda network disk. It basically adds a network drive to your computer. You can also interact with Yoda using the iCommands or the native client from the backend. And you can still then do many of the functionalities that iRODS has, or you can also use the API to interact. So depending on what role you want, what flexibility you want, there are different ways that you can interact with Yoda. So what are the other features and developments that are going on around these three services? For storage, of course, the standard question that you have is what kind of encryption you provide? Do you have redundancy? Do you also have backups? So there are three different storage services that are being used. And depending on which one you use, you have some defaults and some opt-in features. So an example of a default feature is that if you're using the data archive service, which has a backend, it always has double copies, and these copies are in geographically different locations. That's therefore all the data that's stored on the archive. Then an opt-in solution is encryption. So if you want all the data that sits on the self-storage encrypted, then the users can say, I want to opt in for this feature, and we enable it for the users. There's a slide in the end for reference for later if you are interested in seeing what possible combinations of opt-in and default features we have. Then the other side of development is authentication. Now we have all suffered which username, password authentication goes to which site and which server. And the natural way, best way forward would be that if you can use an existing credential also to interact with iRODS or Yoda. So for example, your institutional credential. So to enable that, you basically need a bridge between the institute's identity provider and our services. And in that context, there are two services that are in use. One is called the Surf Connect, and the second one is called SRAM. That's a Surf Research Access Management. And the numbers in the brackets indicate how many of our instances are using them already. So Surf Connects, we have 7 that are in production and is being used by the institutes. That means that the user can just use their institute identity and directly interact with Yoda or iRODS. The second is SRAM. That is being experimented with for one of our hosting instances. We are also busy developing monitoring services based on Grafana. Now, of course, we are talking about data, but you don't just store the data and forget about it. You want to compute. There are different cycles that the data has to go through. So how do the users get the data out of iRODS if they want to use any of the Surf's compute services? So for example, the Snellius and other cluster services, cloud services, we by default enable the iRODS native client. So users can just pull the data from iRODS, finish their analysis and push it back. And this is my last slide. So we have 3 services that are in production. The numbers in the brackets indicate how many instances we have dedicated per institute or university. The Surf team is data management services. Here are the list of my colleagues. And last but not the least, we are also busy into developing the iRODS community edition. I mentioned that these are all dedicated instances, but what about small research groups and institutions that cannot have a dedicated instance or don't need one? Group of researchers who just want to dip their toes and learn about iRODS, or for example, data stewards or managers who want to learn iRODS and have some training. So this is a platform that we are developing for those groups. So hopefully, in the coming weeks, we will already start having pilots. So if you are interested in knowing more about it, please come and find me. Thank you.
Thank you very much. Stay there, stay there. As before, we've got 1 or 2 direct questions on the talk. We will take those now.
In iRODS, usually it's not POSIX system. How do you handle the account of the people to give the access to iRODS?
Well, we don't have repositories, we have the different data sources, but basically we just, depending on which authentication mechanism we are using, either we create a local username, password, or with multi-factor authentication within iRODS, and that's the only one that the user has to use, or if they're using their institutional identity, we automatically, with that identity, create an iRODS user identity, and they can interact with that. So the user is actually blind to what's happening in the backend.
One more question?
Question about unwanted encryption, if there's any attacks and ransomware involved. So what happens if one of the universities is offline for a few weeks? Do you have disaster recovery, or is it actually helping because you have the redundancy and can just switch things over and it does work?
So you mean in terms of data, whether it's encrypted or not, and in case of an attack, or irrespective of
general current cyber attack threats that we have on universities and institutions?
Well, I mean, the first line of defense is that typically we don't have it open to the world. So there are very few servers that are sitting at the university site from where we enable access to the iRODS. So that's the first line of defense. But let's say that that's where it breaks down. We have monitoring in place at the network side and at the local server side to see if this kind of behavior is noticed, and the first step is to shut down. And then if we believe that something has reached the system itself, then we do have the backup service, and there are two kinds of backups that we have. One would be where you're backing up the data itself, and then we have a month-long period, so we can go back to the point in time before which the attack didn't happen, and we can recover that. So of course, there's this danger zone where maybe some data might get lost or not, but then if there's an attack, then that's a risk that we have to take. I hope that answers.
And that hasn't happened yet.
Not yet. And I hope it stays that way.
Good timing, excellent. So we were warned this might happen, but it seems our projector has gone missing. So there may be a little moment between speakers now as the step ladder is brought across. Yeah, let's see if we can get to speaker.
Try not to kill anyone this time.
Right, now, how do I bring up
In the meantime, I've got an online question which might be of interest to Ingrid or Mahili. What are the hidden costs of deploying a local iRODS instance, and what IT skills staff do institutes employ to manage iRODS instances, and how many?
Try first. Yes, it'll be easier. Well, you get one bill. There are no hidden costs, to put it bluntly. So we tell upfront how much it costs per year to have an instance running. So that part is fixed. And then there's a storage on top where you basically have charges per terabyte. And depending on which resource you use, that adds up to how much you would pay for it. For example, Ceph is generally expensive. So that's why we have 3 object store where you're getting disk, which is cheaper. And then there's tape. So depending on your data usage patterns, you can choose what data goes where. You can do some storage tiering to put the costs down. The second part, where what kind of expertise you would need at the institute level. You do need people who know and understand iRODS. So there are different levels of access that we can provide for the servers that we are hosting at SERV. So we deploy, we maintain it. But for example, if you want to have some automation in place, you want to deploy some rule, the person who is in charge on the institute side would be involved in that process. And also we provide advisory work so that you can choose to also opt in for. And that's generally pre-explained and defined. So there wouldn't be like a bill at the end. You would know well in advance how much it's going to cost. And that's also precisely the reason we are working on the community edition, so that for smaller groups who cannot have all these costs, cannot afford it, or just want to test it, but don't need a fully deployed instance, they can use it there. So I hope that answers the question.
Yeah, maybe adding our experience, the cost, of course, open source is never free, but of course you have the infrastructure costs. We have the storage that depends on how large your installation is. And also the infrastructure can be very simple if you have a very small, but as a big institution as us, we have a full cluster where everything is containerized and virtualized. So we have there a CD infrastructure. So that's you need to provide depending on your size. It's a little bit difficult to generalize. It depends. And then in terms of people, a little bit following what has been said already, you need storage, people that knows storage, people that knows DevOps to maintain all the installation. But we also have, and we have a full team, about 5 people, 6 probably in the future, about supporting the users using the system. And that's probably the most important part, where you can really spend a lot of FTEs on helping the users to implement the policies in the system, to implement the schemas, etc. So you can really get very far, but minimal installation, I think Carol was mentioning 1 FTE, I think that's reasonable indeed. Yeah.
So just for those that are in the room, and I'm not benefiting from the chat, Farrell Russell from iRODS, he described that we've found that institutions have typically had 1 FTE and maybe a backup person to run a single zone. To develop and automate some additional work that involves more people, additional talent for teaching, training, integration efforts with additional systems. But to give you a bit of a perspective.
Okay, so I think we've got the technology working again. Apologies for that slight interlude. I will scroll Ingrid off the screen and I shall ask Michaela if you are there to turn your sound on, and I will try and scroll you in, assuming the focus changes as it should do.
Okay, hi, can you hear me?
We can indeed. Do you want to put your camera on, or are you going to remain mysterious?
I cannot turn on my camera, no problem. I'm just working, and yeah,
Brilliant.
I'm here.
We can see you.
Okay.
We can see. Can you see your slides and everything?
Yeah, I can see everything. Okay.
That's brilliant. Excellent. I'm going to step out of the way a bit this time without trying to knock any cables out. But let me know when you want me to move the slides on, and I will do so.
Okay, so thank you very much. I'm Michele Carpene from Cineca. I'm currently working in the HPC technology and middleware group with Mirko Cestari in the HPC Sky department in Bologna, Italy. Now I'm going to give you a brief introduction of the iRODS collaborative data infrastructure, or iRODS CDI, and its services. Next slide, please. The iRODS CDI is the iRODS collaborative data infrastructure, and is one of the largest infrastructure of integrated data services and resources in Europe. It's sustained by the network of more than 20 European research organizations and data and computing center. And recently he signed an agreement to maintain the iRODS CDI for over 10 years, and in 2018 we supported the establishment of the limited liability company, the iRODS Ltd. The infrastructure and the services have been developed in close collaboration with 50 research communities spanning across many different scientific disciplines and involving all the stage of design process. Next slide, please. From 2009, it was a long trip until now. The iRODS project initially started with the development of the data management services and across all the all the specific use case and scenario that have been identified, supporting separation of concern between multiple software components, and the history then moved ahead year after year until the 2021, where the DICE project came, and in order to support the further activities of development and software implementation of the iRODS ecosystem. Next slide, please. Just a very brief introduction. As I was saying, that CDI is one of the major infrastructure supporting research in Europe. Our vision is the data is shared and preserved across board and disciplines, and a set of interoperable service have been provided in order to support also long-term preservation, replication, and many different functionalities within the data infrastructure for research and for all the users that needs to use such services. Next slide, please. The research data life cycle include many different tasks in the workflow, included data creation, data transfer, data processing that can happen locally or on the same infrastructure where there are services deployed, data transfer, sharing data using different kind of services that we are going to see now, like B2Share, and data archiving and data analysis. Next slide, please. Now the iRODS services are presented. This is just a brief overview. The B2Safe actually is the service which provide persistent identifier creation, data replication of collection and data objects in the federation, providing data archiving functionality. At the same time, the B2Share provide a visualization, a web interface functionalities for sharing data, for ingesting and registering data with the PID, and providing also metadata functionality. The B2Find provide functionality like the search and discovery, and the B2Handle provide functionality for creating PIDs and associating PIDs and persistent identifier with the data itself. Next slide, please. Today, DICE will support iRODS activities. It's a funded project with a significant amount of resources for the user. It will be free at the point of use until June 2023, and the service can be used for any kind of activity that the user need, and in combination with DICE services and other providers. Next slide, please. Okay, so more or less, this is the iRODS service suite I was just citing before. We divide these for different kind of layer, following the idea of separating the concern and different behavior for different software components. We have the data discovery, where the B2Find performs search and discovery capabilities, data sharing and access for the B2Share, data management and preservation with the B2Handle and B2Safe, including replication of collection, providing metadata functionality for the data objects, and providing also the capability of associate data objects, files and directories, and persistent identifier in order to retrieve and associate the data object and its collections across the federation for further search and discovery or retrieving. The B2Access instead is the main identity provider, which is used in the iRODS infrastructure, federated infrastructure, in order to provide seamless authentication to the user to services and resources in the federation. Next slide, please. So this is more or less the idea. The iRODS services provide functionalities supporting the idea of fair research of data. So the data repository are long-term data resource repository accessible from computing facilities that can store non-active fair data. The data archive are reflect the policies of the local sites and can be configured in according on it. They are accessible from computing facilities to store non-active research data on the site. The data archive are supported and can provide data archiving functionality to be made accessible again from all computing facilities. And the user in particular are supported with data analysis or processing functionalities or tools that can be deployed on the infrastructure. A lot of customization are possible, and today we support, for example, user in Cineca with a local B2Safe and iRODS installation, trying to support access to data and data objects and collection for the user, and providing also the validation of local policies for the site. Next slide, please. Okay, so here is just a slide that show how the single services map on the various level of the architecture of the schema. In particular, the B2Safe provide replication from and long-term archiving and long-term preservation for the data, and they interact directly with the B2 handle in order to retrieve the PID and associate the PID to the data object. The next slide, please. Okay, I think it's okay. This is just a small panoramic of each component. The B2 find, as I said, allow the user to research data, to perform search and discovery activity, to find collection of scientific data quickly and easily, to get quick overview of available data, and so on. Okay, so basically it's a component that can be integrated also in other web portal or web interfaces, and then can be easily used in a flexible way in order to interact with the underlying iRODS services. Next slide, please.
Okay, 2 minutes.
Yes. The B2 handle just provide the PID creation and registration for long-term preservation. PID mirroring provides abstraction layer between global unique persistent identifier physical location. It's simple to integrate and technology agnostic. Next slide, please. The B2 share just provide a web interface in order to ingest the data, provide PID functionality as well, and recently has been integrated also with the B2Safe in order to connect to the existing replicated data on the B2Safe instances. Is able to register data for publication, share, register research data worldwide, and preserve research data for long term. Next slide, please. The B2Safe, as I already anticipated, provide a PID registration and collection replication and abstraction layer, which virtualize large-scale data resources, optimize access for users from different regions, and bring data closer to powerful computer. The B2Safe interact with the B2 handle and with the other iRODS services, and actually is actively maintained and installed also in Cineca here in Italy for providing replication of data and replication between trusted sites and provide data preservation functionality. Next slide, please. The B2 Drop is a repository for documents or files. Allow storing and exchanging data, synchronize the multiple version, and ensure automatic desktop synchronization. Is a tool that can be easily accessed also as the other iRODS tools through the B2 Access, which is the main identity provider in iRODS. Next slide, please. I think we are more or less.
Yes, I think
yes, I think that was the last one. There were the questions just. Thank you very much.
Thank you very much, Michaela. As we've done previously, I'll take 1 or 2 questions specifically on that presentation, and then we will move on to have a broader discussion. Do we have any questions for Michaela before we move on?
Hello. It's nice to see an update on iRODS, and I was just curious with the metadata contribution. Have you thought about integrating any type of extractors or automated metadata extraction when you have users being able to contribute their metadata to the system?
Today, let's say, in particular, the B2Share service provide metadata schema functionality for defining metadata schema to be associated with the data, and the B2Safe service, which is actually being integrated. So to this extent, we are just managing the integration of the two services, provide also functionality exploited by iRODS, which is basically on the bottom of the B2Safe service, including all that can be provided for as a functionality through rules or microservice. So any schema can be supported, any metadata schema can be validated through the iRODS rules. This is more or less the general panoramica. In the B2Share documentation, the B2Share team provide the structure in order to provide the metadata schema and then validate metadata through the web interface of the B2Share service.
Okay, so they have to pre-register or have their schemas actually associated in the system, and then on interesting metadata, it validates against those schemas. Okay. I think I understand.
Exactly.
Thank you.
One final question before we move on?
Yes, so for Michaela, I find it really interesting to see all the different elements and services that EUDAT provides. And if I'm comparing it to the other presentations, I'm trying to figure out what is that middleware solution in between. Is that iRODS? Are you using something else to tie it all together? How does that?
iRODS is basically the B2Safe service, which currently I'm leading as a service owner, the development on. It's the tool which provide replication, PID registration, and the management of data objects and replica, and is basically based on iRODS in the sense that is a set of scripts and rules provided in a specific directory on the top of iRODS. So iRODS is just the layer, the middleware layer that we exploit in order to provide functionality for data management, data replication in the B2Access. The B2Access in the B2Safe, sorry. The B2Safe simply add functionality, including Python script and iRODS rules, in order to add the functionality of PID registration and also replication following the UDAT policies and the UDAT following the UDAT policies basically. And so iRODS is the basis of the B2Safe service in this sense. This is only true for the B2Safe. The other services, for example, B2Share, follow a different kind of technologies based on different kind of technology, but the two services are going to, of course, to be in the future very, very integrated together in order to provide the same software layer and the same interface, let's say, for accessing data and data objects in the federation.
Thanks, Miguel.
Yeah, you're welcome.
Okay, so we shall move on to the group discussion stage. So I believe, Rory, you're going to lead on this. I should actually introduce us as co-chairs because I realise I haven't done that yet. So my name is James Wilson from UCL, where I'm Head of Research Data and Advanced Research Computing Centre. Rory is the CEO of RSpace. And Keith here is from the Australian Research Data Commons. So I got the acronym correct. Getting there, gradually getting there. And Keith's on the remote duty for people who are joining us remotely. But I shall pass over to Rory at the moment.
There was one question which came in virtually and has not been answered yet. I think it's a question that's probably of interest to most of them. It's about metadata. We can do it now or before we get in. Yes, probably because it's a more specific question.
Let's start off with that then, yeah.
Start off with this one. Okay, so I just need to scroll back because it was a question asked earlier on. Yes, here we go. This is a question from Philip Conzett. Are there any guidelines, constraints on metadata schemas to avoid proliferation and to promote interoperability across platforms and repositories? And Philip asked that question specifically to Ingrid, but I can imagine that it might also be relevant to other instances too. Ingrid, how are you doing that?
Yeah, at the moment, we don't have yet the guidelines because we were at the moment focusing on providing and building the tool, that the tool was there. But we have plans to work together with the library people and the people that really also knows about metadata to provide these guidelines. And we have also the plan to, together with the library, to curate some kind of metadata schemas that will be available, published for everybody in the system. That avoid that the people can start to creating their own and only when they need it. So we will per domain probably, but this is a work that requires some time to understand what is needed, what are the standards that we want to use. So it's work in progress, but we plan because otherwise this is a little bit, for sure we will have at the beginning, we will launch this month, a small guideline of what things that users should think about before creating a metadata schema, not inventing the wheel. And then there was another question about if we plan we use CEDAR. We have been looking at that, not yet evolve farther than that. But so what we have now, the JSON, we work in a JSON format that is a little bit limited, and the people, if they want to import, they will be able to import in this basic, very limited JSON format. But the idea is that we are also able to understand schemas that comes from other systems, well known, for instance, CEDAR, and then we have some kind of translation internally to the system we use. But this is still work in progress.
Just that question, Mahini, how are you doing that with the SERP instance? Is that completely up to every institution to solve that?
Pretty much yes, but I mean for Yoda, they define the schema. So then we rely on the community and their experience to define, because we have so many different domains that we cannot set guidelines for them. We rely on the community, their experience to come up with a good workable solution for themselves. But indeed, it could be nice to have some basic idea in case if they're gonna push the metadata to a repository, then actually they can also check which repository they are interested in and check what guidelines they have and adopt to those. So I think there's information out there, but maybe we have to help the users to find where it is and help them to understand what is useful for themselves.
Maybe I could comment. There's been a lot of discussion in other groups about schemas in this week. Some interesting things, which are relevant, I think. So the bioschema, which is a prominent schema which kind of fell into disuse, is being revived and by a group led by Sarah El Gabali at SciLife Lab. And so if anyone's interested in getting involved in the reviving and re-identification of bioschema, which is going to be used then in SciLife Lab's large sample management projects, so it'll be quite active. You can find out about that. There's also a lot of other work going on around schemas. There's a group at Karlsruhe Institute of Technology that's developed a tool for adding bioschemas to middleware and tools. So it's actually there's a lot of stuff going on. And the CEDAR, which Ingrid mentioned, there's another project that DataCite's involved in, which is an interoperable metadata project involving a whole variety of different players, including DataCite and Dataverse and CEDAR itself, and they're looking at incorporating CEDAR as well. So I think my sense is it's an active area of development and exploration, but it's still quite open and in a way rudimentary what's available now. Yeah.
And a comment that was added there from Terrell Russell from iRODS. He said, regarding metadata schemas and templates, we've seen interoperability and reuse is most likely to happen if they are small and composable. Referencing and translating remote templates is the challenge. Also, local caching and versioning is a real challenge to solve.
Okay, thanks. So, James, should we take questions now, or do you want to try to go through some of these first? What do you think?
up to you. Let's see if there's any further questions.
Yeah, okay,
And
well, let's
then
go ahead.
We can give people some
Yeah.
starters for 10 and get a conversation going.
Yes, thank you.
Question on the, or comment on the composability and the community managing things is the granularity, as you say, because you might have a data set, but a metadata record might not be a good fit for that because the data set contains a lot of different things downstream. So you would want to have the possibility to tag metadata at different corners of your data set, which also allows you to do a graph how they are linked and related.
And are there any tools or projects that are working on facilitating that you're aware of?
So the reason I bring it up is because I see quite a few repositories that have a metadata information, and then some select ones also allow file level or directory level or object level additional metadata.
Okay. Thank you.
I have a question, I think mainly to Ingrid, also to you a little bit, like how active you use researchers in terms of the requirements for the interface and especially naming of fields, because I'm thinking words like, you know, attribute, schema. Those are words that we all understand very well, but if you're a researcher and you're gonna fill this out, you probably need to be quite educated, you know, to know what actually to do. So I was just wondering, like, how did you do something? Try to do requirements from researchers or.
Yeah, that's indeed. I mean, what we see often is the people when things in research data management, they only think on put a place to put my data. That's the first interest, the first concern. And then we are playing a little bit that, okay, put the data here, but do you know there is metadata? And then some people get a little bit overwhelmed. What are you talking about? So we've been piloting the system for more than a year with about 35, 40 different groups. And we've been talking with them a lot about and teaching them and training them. And what's the plan now is basically a lot of training. Indeed, the attribute value unit, that's something we need to explain from the beginning when we start. We are going to talk about metadata. We work using all these, and then we try to translate that in a way that they understand what that means. Most of the people we've seen immediately, okay, yeah, that's the system. It works like that, and they get relatively fast on board. What was very clear from the beginning is that a graphical interface, something that is easy to use, as I show, for instance, I want to add a text field, I want to add, that makes that for them this, and that all the complexity of the attribute value unit gets a little bit hidden in the back end and in the system. And a lot of training, I forgot to mention, we plan to do trainings together with the library about metadata in general as a concept, but then using Mango as the tool to implement it. How do you choose? How do you select a standard? So these are trainings that are going to be happening in the summer and from the summer later on. So there is a lot of interdisciplinary work inside the university. It's not an IT problem. It's beyond that. But a lot of documentation also and training, I think, is needed. And also that the users understand. I think a lot of users get a bit overwhelmed. It is very typical to talk about a schema, metadata schemas and thinking on the schemas for publication that are very complex, very rich. This is an active data, and we try to say, okay, for active data management, you can reduce that, make it the smallest possible, make what is useful for you. You don't need to have everything at the beginning, but get the minimum and start working from that and build up. And because we can compose and combine different schemas, we tend to tell them, build pieces and combine them later. So I think it's a lot of strategies that you need, but it takes, I don't think it's something that users will adopt from day one. I mean, some of them will put the data and do nothing with this metadata, and we need to encourage them to go further.
Okay, thanks. So, yeah, sorry, go ahead.
Great. What Jurgen Moers from Utrecht University. What I find very interesting from your story is the relation with Mango and the iRODS middleware over the whole life cycle of research. It's not only the data management, but also showing instruments that are connected and communicating and pushing data back and forth. I think that's the next step to, how do you call it, to make the researchers aware of the facilities and the infrastructure that you're actually building here. So that opens up a whole world of the data management processing transfer that they need. So I think that's a very strong point in selling the solution of Mango. At Utrecht University, we're now currently looking at iRODS, we call it iBridges as a project with 2 other universities to make that data processing via a laboratory like eLab journals the same way as you are doing that. So you're providing, let's say, a suite of services based on that middleware with good graphic user interfaces, easy to use for the researchers. And I think that's the selling point. It's a one-stop shop for all your whole research cycle, and not only the data management. I'd like to stipulate.
Yeah, actually, that doesn't need to be one system, actually. What you need to present it to the users as one system or integrated enough that it gets us smoothly to move between. So we have a lot of work. We have what we call the RDM Competence Centrum on selling the RDM tools all together in one pack, even if they are and working together on integrating them as much as we can, that for the user is one click to move one to the other, because it's also not realistic to think that one tool can solve all the problems on the whole life cycle. But I mean, for instance, Mango is only active data. Yoda, for instance, is the full life cycle till publication. We have another repository based on Dataverse for publication. So, but we are going to try to that the user can move the data pool in the 2 directions, from Dataverse from iRODS to iRODS from Dataverse. So make them easy for the users and choose which one works for them. And I think that's indeed very important, because we often hear from the users that, yeah, switching between tools makes their life very, very uncomfortable, because every time is something new. You know.
Well, on the community of astronomy, we have the research of data are mainly on metadata. So we have a set of metadata which are standardized by a community, which is International DSL Observatory Alliance. And then when we make a query on that, we find what we want, and then we get the data but they are not, they are open. So it's quite easy in this case to access the data. And the main problem is to define the way to standardize the access to metadata and to standardize the metadata. But the things beside can be iRODS or whatever you want on the server side. For us, what is important is to have a layer above that.
And what does that layer consist of?
Well, a bunch of standards to define the metadata, to define a way to query the metadata, right, to define the standard to exchange the metadata, and then to have the bunch of metadata sufficiently precise that a machine can compare to kind of 2 data from different origins.
Okay, I think that's a great seg into this first question here. Besides iRODS, so if I try to reflect on what we've heard this morning, so the first Ingrid's presentation was about iRODS as middleware, which is informing kind of a value-added middleware system. Then the second presentation was about delivery of iRODS as middleware to different universities. The third presentation was about EUDAT, which isn't really middleware, it's a whole system of services which incorporates iRODS. And then the last comment is thinking of middleware more as a set of standards, so different concepts of middleware and what it fits in. But it's interesting. So to be perfectly frank, when we first thought about this session, we thought iRODS is good, and then we thought, well, yeah, but we should have some alternatives to discuss as well. And frankly, we were finding difficulty coming up with direct alternatives to iRODS. What we've now seen this morning is kind of different layers, different ways of putting it together. But thinking more directly about alternatives to iRODS, other kinds of middleware, are other people aware of or using other kinds of middleware? Any examples? Sorry.
Yeah, we're starting to explore using, it's not open source, but it's called Starfish. It's a very rich meta file management, but orchestrator across your organization. So it doesn't do everything we want to do, but it's pretty rich and robust middleware solutions.
Yeah, Starfish is one. I know Starfish as well. Yeah, so yeah.
Yeah, I think in the field of particle physics, they were the ones to have the biggest data a long time ago, and they have solved it for themselves. And we have had some pilots to see if we could reuse, because it's all open source, to make it usable for other communities. But it was so well defined for the data and the workflow of particle physics is that it would take a huge amount of adoption and, you know, wrapping things around it to make it usable for the researchers. So I think any middleware we use will have to have some layer on top, either that's so agnostic that everyone can use, but then it becomes too complex because then you have to do the homework, or it is dedicated to a science field, because researchers want the data managed. They don't want to do data management. I don't think they care about it. They just want their data, do the research, and that's it. And I think the way we try to facilitate it, in fact, wrapping it in a whole research cycle is perhaps the way to go, and one middleware or other layers on top are not going to be the solution. Like in case of iRODS, there are a lot of institutions who want to use it, but their biggest drawback is, oh, but our researchers don't want to use command line. Then we say, okay, here's Yoda. How about this? Because it supports web-based workflows. And they say, yes, but I have a list of these requirements. And the lists are somewhat overlapping, but they're always different. And the number of people we have with the amount of work, it's not possible to support all of them. And I think that's the biggest challenge.
So yeah, so I think that segues nicely into the second question, which is up here, also reflecting on what we've heard this morning. So we had the example of Surf, which is offering iRODS as some value add, but mostly an iRODS service to make it more accessible. Then we had the Mango example. We had talking about Utrecht, which are kind of turning middleware into a more of a system, more of a value-added research data management platform with things like the UI. So the second question is really, how do these, and then someone asked the question, well, how can every university use Mango? Well, can every university use whatever it is that Utrecht develops? Well, and then we have other national bodies, which are other national. So how are these things going to get delivered and get beyond individual kind of experiments? Is it the way to go through the NRENs, things like SURF? Is there more of a kind of peer-to-peer, university to university help? Any thoughts around these issues are kind of the next step? Yeah, Mark?
Not directly on your point, Rory, but just kind of maybe to segue from the previous question. One of the pieces of middleware that seems to me to often be missing from the conversation. So these systems are great. They use the policy-based storage framework to determine where to store the data within the institutional or kind of central service like SURF. But one of the kind of key missing opportunities I see is, however one does it, there's a platform called DataSeer, which uses AI to determine the likely best practice location to deposit a data set associated with a research article. So it seems to me with institutions that are creating this middleware, that one of the really useful researcher-facing services would be when they get to the point of publication, and we would normally put it into, say, a Dataverse repository. That's a great place to look at the nature of the data set and say, well, given your discipline and the nature of your data set, the best practice repository is X. So whether it's a genomics data set or whatever it is. So that would be a really nice service. And I've been kind of talking to various people about this over the years, and it seems that it seems to be dropped in favor of the local institutional,
Yeah.
whether it's a preservation service or best, whatever the.
Or a data steward or whatever.
Yeah, so if we could add that into these middleware services like the Mango product, I think the researchers would flock to it. Because, we could typically use APIs and best practice repositories to insert a data set, then that, presents the preferred metadata profile for that repository. So it solves a lot of interesting problem, I think. So I'm interested to see if anybody has thought about that kind of data seer service and inserting data, maybe not just in the local repository, but also in a best practice domain specific repository.
You have a comment there? Or go ahead.
Go ahead.
Well, I think it's a really great suggestion, and I don't know if this overlaps a little bit with the data brokering. But at that, where you're going between like a localized management of data to community management, depending on what your localized resource is, and how you're, and registries are really good for that too, because when you get into registries, you could actually type repositories or type, what kind of semantic assets different repositories have. But I think it's a really great suggestion that there may be some overlap with some of the data brokering discussions at that function.
I have a comment. Sorry, go ahead, Natalie. I have a comment on Mark's comment. Yeah.
So to say about domain specific repositories, I don't know if there's anyone from TU, 4TU or DANS here, because they do have, like, for example, the 4TU, they have a repository and they say it's more focused on engineering and science. At DANS, they have also what they call data nodes, and then they kind of target specific communities. I have not looked up how it looks myself, but I'm sure if they're targeting a specific community, then all the workflow metadata is also probably oriented towards that domain already.
Yeah, because
They do exist, but maybe it's just not common knowledge.
I think Mark's point is about the discovery. There's too many that exist.
Yeah.
How do you discover them and then use them? The point I was going to make, Mark, just is that you need to be thinking about this at the beginning rather than at the end. So it's not when you come to deposit, but if you're going to have a schema, if you're going to be using IGSNs or PID or whatever, that actually informs the very beginning of the research workflow. But in order to do that effectively, you need to know the answer to the question which you said, which is what are the registries and repositories where you can't find that out now. So if you had something like what you're describing, I think it would be very useful both in the design of the systems to build in early on the ability to make that discovery, and then at the end, then it would be easy to make the decision. But yeah,
I'm going to say no, it's not cultural. Cultural is not the right word, but we have our institutional repository frameworks often located in the libraries, and we have the domain communities of practice repositories, many of which are reflected in a registry like ParaShare. And I find that the two communities tend to kind of operate within their own inside baseball bubble. But if the expertise in that kind of academic library metadata expertise community could use, there's a lot of great tools out there that can automatically determine the nature of the data set, go to a fair sharing, use a data seer, and both deposit in the best practice domain repository and put a copy in the longer term preservation storage reflected in a service or something like that.
yeah, you have a point.
Yeah, I have a question. Is this about depositing the data set or publishing the metadata?
Well, for me, it's both, because you typically don't deposit a data set without a metadata record.
But you can also, for example, have your metadata published in many repositories, which all refer to one local at your institution,
Yeah.
which might also be a solution.
This is now a little bit going back to the original question of how other institutions are using middleware. I'm a data steward from a non-university research institute in Germany. And we implemented iRODS and Yoda for our institutional data archive. And I wanted to emphasize that the problems that you mentioned of granularity and the overwhelmingness of which metadata schema should I choose resonates very much with me, because that is a barrier to adoption. Like we're talking now about data sets, but if you use Yoda like it was intended with the research space, where you can just put in all your stuff that you're working on and then have the metadata only on the folder level, that is kind of difficult then to handle and to tell people, yeah, well, you have to put in as much metadata as possible to make it useful for you and everyone else. And then it's not granular enough.
Thanks, Keith. I just struck me, we have been not very polite in not checking in with the other, must be online questions and stuff. You want to take any of those, or?
Yeah, so there's not been that many.
Not many, okay.
There were some earlier. There was one comment here from Matt Chandler. It's not a question, but just adding into it. So Princeton University, this is coming back to the first question. What are the middleware solutions? At Princeton University, we've also been experimenting with Starfish as well as Architecture Media Flux. So, and I do also know this from personal perspective, in Australia, there's been at least 2 universities that have built their own systems, very much tailored to their own local situation. So I think there are a few different solutions out there. Otherwise, no, I think we're up to date with the questions.
Okay, then let me skip to the sustainability question, which relates to my earlier point about, okay, there's a lot of experimentation going on. iRODS seems to be incorporated in many of them in one way or another. The things are being built on top of iRODS now. Well, sustainability, but also kind of, do people have a sense of where things are going? So we have something like Mango, what I forget the name of what the one Utrecht is developing, maybe
Yoda.
Yoda. Okay, you're Yoda, all right. So how do people think this is going to? It's not, you can't talk about sustainability in the long term, but at least in the short term, how do people see the next couple of years developing? Do you see any trends or any? Yeah.
Well, our storage is quickly filling up. And especially with large images, for example, from electron microscopes and these big instruments. So we also need to think about policies, like which data should we store, and yeah, for how long, and maybe we should not store all of it, but
at low cost storage facilities, being able to push things in the right direction.
Yes,
immediately,
it's
you know,
like taking photos with your smartphone. You don't delete them, right? Just so maybe that's not sustainable.
Yeah,
because it keeps on growing.
I was just gonna throw the word that everybody loves is cloud services out there, but you know, they're really growing out in the cloud to provide all these middleware orchestrated services too. So I was just wondering, you know, is that something that factors into this? Are people deploying iRODS out into these architectures? But there are a lot more modern cloud kind of middleware tools rolling out. It's hard to keep up with everything that Amazon has to offer, but
actually, that would be good. I think Terrell Russell from iRODS is on. I believe he's on the call. So Terrell, if you're out there in the metaverse, I know obviously you've thought a lot about this. So would you mind commenting on that?
Yes, I'm here. Hello, everybody. We're in the school. We're in the school drop-off line, so this is exciting. Yes, the cloud services. We've seen a lot of people start moving there, but maybe only for bursting or for capacity planning. A lot of European institutions still have some, we'll call them existential crises around GDPR and these, you know, largely American cloud companies. And so that's not a solved problem. Obviously, the costs are also falling, but they're still pretty high. And so if you are of a certain size, there's still a break-even point where it makes sense to have your own data centers. probably not at necessarily a medium or small size institution. You have to be pretty big or some kind of conglomerate aggregation consortium, and then it might make sense, like a SURF, to have your own data centers in terms of price. But yeah, it's not a solved thing, but at the same time, that's, there's a lot of money in the corporate space, and they are developing the GUIs and the integrations at a faster clip than the open source space. But obviously, living in where I live with my open source hat on, I think we eventually catch up. And with the institutions that we deal with, largely academic, largely governmental, federal, the 100-year plan is a very real thing on the table. People have to have a plan that outlasts, the lifetime of a corporate entity or a service. Yeah.
Thanks, Gerald. I have 2 points to add there. The first is that might be a reason to turn to an NREN like SURF, which can help find more, a cheaper or better deployment and storage. The second is just that makes me think of Mass Open Cloud, which is an initiative between Harvard and Northeastern and MIT BU and UMass, which is built an open cloud, like an open source cloud, which is very much meant to be an alternative to the commercial providers, and it seems to be fairly sustainable so far. It exists, and it's still free, but they're going to start charging, and they say that it's going to be half the cost. They say it's going to be half the cost of the big players. But the point is, it's open source, so they have hundreds and hundreds of computer scientists who are contributing to this. So that could be an alternative source of things like Mass Open Cloud could be on the turf as well. Yep. Tammy.
The last thing that really made me think, a lot of the students and even some of the scientific groups I've spoken to, they really don't trust necessarily in cloud-based systems, but I also feel like sometimes they don't also necessarily understand what they are and aren't trusting in. So they won't put things in cloud systems, but they have a memory stick. Oh, that's password protected. If I stole it, could I get your data? Oh yeah, and I was like, if I just took your lab book, could I have your data? So there's a lack of education and understanding in the different cloud offerings and where it isn't actually secure. And I feel like that definitely needs to be addressed to persuade more people that they can put their data somewhere safe.
Great, thanks. We've got 30 seconds left. So unless I have one final question. Yeah.
Well, it kind of addresses the last bullet point, which we didn't quite make it to, so maybe that's good for the last 30 seconds. In terms of sustainability and future development, coming back, I don't know your name, but coming back to your point about it just gets more massive. How do we maintain and manage it after, the data after we put it somewhere? And I feel like I'm not familiar with all these systems, so maybe that's already part of them or on the development roadmap. But the idea to, once you've stored your data, managed it during your life cycle, how do you address the permissions to people who maybe come along later in that road in the institution who aren't a part of that project, so PIs, or how to deal with the sharing so that you can decide what needs to be deleted, and also like metrics or dashboards that help you evaluate your data over time. So we don't just keep storing it and then just have, yes, we have some policy guidelines, oh, delete it after 10 years. How do you actually evaluate? Should I delete it? Was it used? What is it valuable? So adding some aspects to this middleware that can help with that, I think would be a really nice thing for sustainability.
Okay, thanks. And then Natalie, one final comment, and I'll leave it to you to wrap up, James. Or...
But the commercial versus the local, whatever, network transfer costs, those are the biggest killers. And then for the trust part, what SURF is now doing is that if we have cloud service, but of course we can't match the scalability of Amazon or Google. So we work with them, we tender with them, so the researchers can trust. We do the trust part, the legal part, that the data will never leave EU. It's sticking to GDPR, and we offer them scalability and the cost of it. So maybe that's one way to solve somewhat the scalability problem.
Okay, thank you very much, James. Do you want to wrap up?
Sure, yeah. So I think that was a very good session. Thank you ever so much for all your contributions. I think that was very useful. I'm not sure there's much more to say now. So we're running out of time. Lunch awaits. So just thank you to everyone for participating in the session. Thank you once again for all our speakers. Just give them a round of applause before we head off.
those who are in the room, the collaborative notes document's got some interesting things in there. The chat also came up with a bunch of interesting links. So I posted them in the collaborative notes documents. Have a look at that. There might be some useful stuff there.
Brilliant. Thank you all.
Nice chat. That was a good one. Yeah, I'm from this.
Oh, you're from this, okay, great.
Yeah.
And the whole session was like, how do I know? And like, yes, yeah, do you introduce
Of
yourself?
course, yes. No,
And that's like, know exact line.
that would make sense. Yeah, you do.
Yeah,
There's so many people around. So I know who you mean. Yeah. No, I keep having that. Yeah, pleased to meet you. So I think that's going to be in person only. It's up in London. So yeah. So I suspect the answer will be no. So I'm trying to encourage my grade students. I'm rapidly trying to recruit. That's probably won't do that. You're a shame. Yes. Yeah, I've been to the SDS meeting for quite a while. When do you start going? Yeah, okay.
So yeah, I've been to France and I've been to
Combination.
So yeah, the Nikki and I Breakout.
Right. Yeah. Yeah, I'll see if I can get it to London next Wednesday. Because I live a little bit out. Expensive. But I think it was at least one. No, that'll be my start. Thank you very much. Yeah, no. Yeah, no, if I can't make the next FPS one, then hopefully one of the
send out about
Jeremy Frey was using, he was using laptop. We're now trying to translate that into something that can stick in our repository. Actually, that's been picked up after UCL.
we have that way we can understand it, not enterprise.
No. Okay.
I think it's interesting. Some unis are recommending one, some have guidance. What I kind of really wanted together was guidance in Canada, trying to find and make this. So if all the
yeah, that'd be fine. Yes, and one of those have a, yeah.
I found some other reviews again, I'm maintaining. Like, how about state community? I don't think it's